Hi, teacher.
Hello, Musa. How are you?
I am fine. How about you?
I'm good. I'm okay. Thank you. How was your day today?
Normal.
Did you go out for walking, for shopping, or for anything?
No. Anything?
No.
Yeah.
Did you play?
Everywhere is closed. Everywhere is closed, and we again had online education.
Even shops? How about supermarkets and shops?
No, supermarkets are open, but we had anything that we need at our home.
Hmm. But if you want, can you go out? Is it okay?
Yeah.
Hmm.
Yes.
I see. Okay. Mr. Makka, good to see you. How are you?
I'm fine. How about you?
Good. Thank you. So Musa, I think the Sasmo is going to take place in the last week of April, right? Like maybe 26, 27, or 28. Did they tell you anything about the Sasmo date?
No, they just asked, what is the number of my school?
Hmm. Okay, I think it's going to take place. So that means that we have 3 more weeks, okay, including this week. And after that, Musa, Maka, you are going to have maybe a lot of rest, okay? So don't give up, don't stop, okay? Just 3 weeks. So practice as many questions as possible, even the past papers, especially the questions after 15. You need to practice one more time. Now let's continue. Last time we started this paper S2 from 2016, and this week, today we are going to finish this. And Wednesday we will start 2017, and after that we will see maybe 2018. So we stopped here. Today is April 5. All right. Actually here. Okay, Maka, can you read the question?
Okay. There are 13 regions in the diagram on the right. Each region is to be painted with one color. What is the least number of colors needed to paint all the regions so that any two adjacent regions do not share the same color?
Okay, what is the least number of colors needed to paint all the regions so that any two adjacent regions do not share the same color? Okay, that's again, I think we did similar questions before. It's like just we need to use the
Yes, we
idea
did.
of coloring maps, right? So how many? We can just do this together. Maybe this is the first question. As you see here, to solve this kind of problems, we need to start from the region where it has the most number of borders to other regions, right? Just if you look at this, the center, the circle in the center, right? That is bordered to many parts of this one. As you see here, I'm talking about the center. It is bordered to this 1, 2, 3, 4, 5, 6. And that's why if you want the color, we have the color from the
Eight,
center. All right,
eight,
8. So now suppose that we have some different color. Let me just number them. Color number 1, color number 2, color number 3, color number 4, color number 5, blah, blah, right? So suppose that for the central part, I use color number 1. So now if I just move out, right, now here I should use different here. Let me use here color 2. And how about here? Also, I cannot use color 1 or 2 because they have adjacent regions, where they are adjacent to each other, 3. But how about this one? I can use 2 here, right? Because 2, it is actually, what is it, 2, 1, and 3, right? And the 2 is here. With 2 and these two twos, they are not sharing any border. So now I will continue here. How about here? I can use 3 here again. Now I use 1, 3. How about here? I can use 2 here again. But here, unfortunately, right, 1 is bordered to 2. And how about here? Can I use 3?
Yes, you can.
I can use 3, right? Yes, I can use 3 here. 1, 3, 2. 1, 2, 3. 1, 3, 2. 1, 3, 2. 2, 3, 2, 3. Okay, good. So now we are just moving out again, 3, 2 here. So I need to use something different. Let me use 1 here. But 1 is bordered to 2 here, and also 3, right? So now as you see here, I cannot use color 1 here. Otherwise, it is adjacent to 1, right? Which is forcing us to use different color here. There's no way. So
For
I'm going to use new color here, this 4. So with this 4, I can use here number 1. And also here I can use number not 2, not 3, not 1. So I can use number 4 again. And how about here number 1 again and 3, 2, number 4 again. Now if you try with 3 colors, you can see that it does not work. Okay, so that means at minimum, at least we need to use 4 different colors under this condition. No 2 adjacent regions share the same color. Okay,
Okay.
good. Next question. Musa, read the question and you are going to count this, and after that we will discuss it together.
How many triangles are there in the diagram below?
So again, as I say here, in every year in Sasmo paper, they ask one similar question. How many triangles, how many squares, how many rectangles? So if you do not count them in a systematic way, you may get confused. That's why just count first how many triangles do we have here that has only one part, and after that the triangle that has 2 parts, and after that maybe 3 parts and 4 parts and 5 and 6 and 7 and 8. In this way, if you count this, actually you can just get the exact number of triangles in this figure. Okay, let's count this. Let me see how many we can find, and after that we will do it together.
Teacher, I found D41.
41, are you sure?
I think it's 41.
Not more than that?
Maybe.
Hello, teacher.
Hi, Daphne. How about you, Musa? How many did you find?
I'm still counting. At least I have like, uh,
Still counting?
at least I have maybe uh, 30 or 40, but there are a lot of triangles.
Sona, how about you? How many did you find?
I'm still not done yet.
Okay, keep counting. Maka, did you also count the biggest triangle here?
Yes.
Like this one, for example. Let me just write here. A, B, C. Can you see that?
Yes.
Really?
I counted it too.
So, okay, now if you just tell me how many triangles did you count, which has only one part? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 20, right? At the top and bottom. And how about a triangle that has two parts? How
9.
many? It is 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13. So that's 13, right? And we don't have any triangle that has three parts because it doesn't form triangle. And how about the triangle which has four parts, right? If you look at this, let me just write here. This one is 1, right? This one is 1. And also this one is 2, right? The same thing at the up, it is 1, right? And also this one is 2, right? And how about these triangles? This one is, okay. How many do we have with four parts? Is this 8?
It's
Uh,
8.
like 4, like, let me just write here. This one, 1, right? Okay. And that one is, okay. This one is 2, right? And now here, this one is 3, right? And this one is 4, right? Only 4.
We have more four more triangles, maybe.
Oh, 4 more
The
triangles,
bottom
right? This
right.
one. Let me just use red here. And also this one, right? Here we have, I didn't count this one. I didn't count this, for example, this one, right? And also the same thing here. How about this one? And how about this one? Well, that has 4 parts. So altogether we have 8, right? And after that, the big one, let's say A, B, C. It's a big one. And how about D, E, F? Let's look at that has 8 parts. So that is 2. So altogether it is 43. Any objections, Maka?
Teacher, I didn't count the two of the four parts.
Also, it's a bit hard, that's why I'm using different color. Otherwise, it's confusing here. So that's why you should be carefully. Uh, maybe because it's symmetric, just you need to count the triangles, for example, in the bottom part. And after that, just multiply by 2. If you count like this one is number 1, and this one is number 2, and this one is number 3, and this one is number 4. The same thing goes to the above part, right? So that's why it must be 8, because it is a symmetric shape. I mean, figure. Okay, Musa, you need to practice again, count again, all right? In Sasmo, the biggest challenge is time. Okay, if you do not manage your time well, you will not be able to solve the questions in a given time, because 25 questions, only 90 minutes, that's the biggest challenge. And number 2 is you need to think fast and solve the problems fast. Otherwise, let's move to the next question. Musa, read the question.
5 circles are drawn in a flat surface. What is the greatest number of regions that can be formed on the surface?
Guys, can you try this? Okay, here it's about accurate drawing. And we know that when two circles create or form the biggest number of regions when they intersect each other at 2 different points. So can you draw 5 circles so that if you just pick any 2 circles, they intersect each other at 2 different points? At that time, actually, we can form the most number of regions using 5 circles. You have 2 minutes. If you don't have actually a compass, you cannot draw the circle accurately. So Daphne, are you back to Azerbaijan? I think you're sitting in your room.
Yes, teacher.
Yeah, I can see that. How many days did you stay in Turkey? 2 weeks?
Yeah, exactly 2 weeks. Like 14 days, I guess.
Good. Maka, are you sure?
I don't know.
Very close, but again, it's the wrong answer. But very close. Maka, did you count the region outside the circles as one region?
Yes, I didn't count it second time. It's the second time.
No, I mean, did you also count the region
No, I
outside the
didn't.
circle as a one region? Do
No.
you understand what I mean?
Yes, I understood. I understood.
So including that one, you got 21,
No, it's 22.
22.
My answer is false.
Yeah, I mean, if it is 22, that's the correct answer. And because here, if you do not use a compass, right, if you don't draw nicely, it's a bit hard to see all the regions. And that's why, for example, let's just draw this with, like, let's say the first one is, let me draw the big one here. All right. And after that, select. Can I just copy it? No. Anyway, let me draw another one. Okay, here we have, whoops. All right. Let's do another one here. We have another circle and move this, right? They must intersect each other 2 points. And I draw another one. Let me just choose circle and make sure that it will intersect with other circle at 2 different points. Let me just draw like this. Okay, 3 circles, and we draw another one. Let's say this blue, right? Again, just make sure that it will intersect all circle at 2 different points. Is it? Yes. And the last one, okay. Is it? Did I draw 5? Yes. Now if you just count one by one, how many circles do we have here? Starting from the smallest one, maybe this one is here 1. Here we have 2. This one is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Teacher, you already counted the 19. It's 2.
Huh?
Teacher, we have between the 7 and 16. There is the 21.
Where?
Yes. Between like 15, 8, 7, 16, and 17.
Here, right?
First
And
is
see
that
here.
encircling, teacher, you counted twice, like the 2
Where?
or 19 twice.
Where?
2 and 19. They're the same place.
Okay. Let's say this one is, now it's 18. This one is 19, right? This part is, let's say this 19. And this one is it 19? No.
No, teacher, you already counted that. The one
Okay,
like
this one
there
20.
is 20.
Did you have between 2 and 4? Did you count this?
2 and 4.
Yes, he
Yes.
did. It's one.
One is missing, right? Actually, that's why if you don't draw nicely, maybe with compass you can draw this. Actually, if you just pick any two circles, they must intersect each other at 2 different points. Where did I miss here?
Nothing is missing.
There is a little one between the 18 and 13.
18 and 13. Oh, I see. You see Daphne here? That is 21.
Yeah, okay.
You have eagle eyes, you know, Maka. And outside here we have 22. Okay, so that is 22. But is there any algebraic way? I didn't find yet, okay, but the only way is you need to draw accurately, make sure that any two different circles here, they intersect each other at 2 different points. At that time, we can form the most number of regions. That is the point here. So if you draw 5 circles, we can create how many regions? 22. And also, don't forget to include the region outside these circles. Okay, good. Nice, Maka, thank you. Let me delete my, okay. Sona, are you here?
Oh, yes, I am.
A long time we didn't hear your voice. Can you read this question, Sona?
Yeah, sure. How many fractions are there in the sequence below?
Oh, how many fractions are there in the sequence below? Very easy question. Let's see. You have 1.5 minutes. Daphne, what happened to your face? Why is it so red? Is it because too cold?
No, it's just the camera. It's not the thread actually.
Oh, you look so
Teacher,
different.
is it like never E?
E?
Yeah.
None of the
It's
above?
always all the time like none of the above, and it's always one of the answers almost.
No, no, no.
But
The
I
answer,
found how they
answer is
like
not E.
I found how they make like the fraction.
Okay.
Use
Can you
what
tell me the pattern? What is it?
method?
What is it? Tell me.
Um, like one first fraction 1 plus 3. It give us 4, and 4 plus 3 is 7. 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 11 is 29. 29 plus 18 is 47.
It's like Fibonacci numbers, right? If you just look at this, here we have 1 and 3. 1 plus 3, it is 4. 3 plus 4, it is 7. 4 plus 7, it is 11. 7 plus
Yeah.
11, it is 18. So if you just continue writing in this manner, right, here we have 29 plus 47, that's equal to 76. And 47 plus 76, that's equal to 110, 123. And 76 plus 123, that's equal to 199. And 199 plus 123, that's equal to 322. And now 322 plus 199, 521. And 322, 521, that's equal to 843, right? So now 521, 843, that's equal to 1364. And 1364 plus 843, that's equal to 2207. How many? 1, 2, 3, 4, 5, 6, 7, 8. So here We have 8 fractions.
Yeah, I got the same answer.
Okay, Daphne. It's like a Fibonacci sequence, right? Just to get the next term, we need to add the preceding two terms. And also in this way, we can continue. And how many numbers do we have until 2 to 0? 7. And just divided by 2 because we are using two numbers to form a fraction. That also gives us the number of fractions here.
Teacher, or we can just like learn the whole Fibonacci sequence and then figure that out. That's easier.
Okay, good. Daphne, can you read this? Oh, it's a long question.
The bar chart below shows the numbers of cards sold in town A in the first half year 2015. For example, 73,000 cars,
What?
100 cars were
7,300
sold
cars.
in January, while X thousand cars were sold in February. The number of cars sold in the last 2 months is not indicated in the graph. The percentage
Indicated.
increase
Indicated.
The percentage increase in the number of cars sold in February to June is 70%.
40%.
Number of cars sold in May is 2,800 cars, less than twice the number of cars sold in June. The product of the numbers of cars sold in May and June is equal to 700 117
Million.
million 60
600.
600,000. How that too many cars? How many
600,000.
cars were sold in February?
Okay, guys, here starting from 2016 in Sasmo, they actually started asking one statistics question. This is a statistics question. Now we are talking about this bar graph. Or say, as you see here in the question, it's saying that the bar chart below shows the number of cars sold in town A in the first half of year 2015. So in January, they sold 7.3 thousand cars. In February, X thousand cars. And in March, okay, in April, and in May, we don't know in June. But let me just start to understand this together, and you will solve this. And it says that the number of cars sold in the last 2 months is not indicated in the graph. Okay. The percentage increase in the number of cars sold from February to June is 40%. So what does it mean? It means that in February, X thousand cars were sold, right? But the percentage increase from February to June is 40%. So that means that X plus 40% of X, that is equal to the number of cars sold in June, which is equal to 1.4 X cars were sold in June. Now we'll continue. Now the number of cars sold in May is 2,800 cars, less than twice the number of cars sold in June. So that means that the number of cars sold in May, right, it is 2,800, less than twice the number of cars sold in June. So that means that here, let's say equal to 2 times 1.4, and immediately let me just write this 2.8x minus 2.8, because 2,800 is 2.8 times 1,000, right? That is this one. So again, we'll continue. The product of the number of cars sold in May and June is equal to 117,600,000. So that means that again, this one I can write it as 117.6 times 1,000 times 1,000, right? Why am I writing like this? Because it says that here, this one is this many thousand, right? And this many thousand. So that means that here we have 2.8x minus 2.8 number of cars sold in May times 1,000, right? Times number of cars sold in June, that's equal to 1.4x times 1,000. That is equal to 117.117.6 million. And let me just write it as 10 to the power of 6. because I'm just explaining here. We have never solved this kind of question before. Maybe if I give you more time, you can solve this, okay? But it's the first question, that's why we are doing it together. Now this 1 million, right? 1 million, they cancel each other. Here we have 2.8. 2.8 is a common factor. And also here we have 1.4. So what is 2.8? 2.8 times 1.4, 2.8 times 1.4, that's equal to 3.92. So here we have 3.92. In the parentheses, here we have x minus 1. Also here outside, here we have one more x. On the right hand side, we have 117.6. Or that's equal to x times x minus 1 is equal to 117.6 over 3.92, which is equal to, that's equal to 117.6 is divided by 3.92. That's equal to 30, right? And on the left hand side, we just have the product of two consecutive numbers. And also we know that 30, we can write it as 6 times 5. And other roots will be negative here. So the only answer here is x should be equal to 6. So that means that in February, 6,000 cars were sold. Usually statistics question, okay, they are big because you cannot ask statistics question in a short form. But you should not be scared of the question that actually has a lot of words. Read it well, understand this. Once actually just express everything in terms of algebraic equation, the rest is very easy. Okay, Musa Mamedov, any questions?
No.
Good. I don't know if it's good or not, because we need to have question, right? Okay, let's guys continue. We are running out of time. Musa, read the question.
There are 27 students in the classroom. 14 of them wear glasses, 11 of 27 are girls. Only 5 boys don't wear glasses. How many girls wear glasses?
How many girls wear glasses? Very easy question, guys. You have 1.5 minutes. Try this, okay? And I hope you will get the right answer. Definitely write on a piece of paper. Are you trying to
Do I
solve
have
mentally?
to? Yeah.
Let's see.
Teacher, I actually don't solve mentally, but you can say that. I mean, I use everything instead of a paper.
Okay. Could you solve it? What did you get? Already Maka solved this so fast and his
You don't
answer is
need to be a
correct.
genius to find this. It's 9.
9?
Yes.
No. Musa, how about you?
I
I'm
forgot to read the
7.
don't.
There are 27 students in the classroom. Okay. 14 of them wear glasses. All right. 11 of the 27 are girls. So that means that here we have 11 girls, right?
16
And
boys.
only 5 boys don't wear glasses.
It's 5.
So how many girls wear
Teacher, it's 5.
glasses? Huh? Here we have number
5.
of girls, right? And here we have number of boys. Anyway, here we have girls. Let me just write like this. Number of girls who wear glasses, right? And 14 of them wear glasses, and 11 of them of 27 are girls. Okay, that means that if this one is X, this one is Y, this one is Z, only 5 boys don't wear glasses. Maka, how do you solve this question? I'm confused.
We have 11 girls and 16 boys. That means, and 5 of the boys don't wear glasses. That means we have 11 boys wear glasses, and only the 14 students wear glasses, and 14 minus 11 is 3.
Yeah, that's the easiest way.
Yeah, I
Very
got
good.
the same answer.
Very good, Maka. Thank you. So 11 of the 27 are girls. That means that 16 of them are boys. And only 5 boys don't wear glasses. That means that 11 of them wear glasses. And 14 of them wear glasses. So 14 minus 11, the remaining are girls. Only 3 girls wear glasses. So that means that in this class, boys are smarter than girls, right? I don't know. Usually people say that the people who wear glasses, they look smart. It is true or not, I don't know. Right, Defna, do you know that how
Teacher,
many
the thing
students wear
about it is
glasses in your
like,
class? Huh?
teacher, actually nowadays a lot of people wear glasses. But the thing about wearing glasses and looking like smart is because when they work a lot, their eyes, because they look like close up to things like reading a lot, or especially nowadays working a lot from a device, they can get their eyes a little bad. So they need to wear glasses. But
Yeah,
most of the time, especially nowadays, are those who are like gamers or who just people spend lots of time in front of the screen, or whose job is to spend time in front of the screen. So
yeah.
that's why
Especially it
I don't
depends on
think
what.
nowadays smart people are the only ones who wear glasses. But like I said, it's just like a straight stereotyping when they say like people who wear glasses are nerds. Actually, sometimes like some people who don't really have like something wrong with their eyes, they wear glasses without like the glasses inside of them.
Yeah, yeah. It depends also, where you are living. But here in this part, for example, if you come, a lot of people wear glasses. But if you go to Uzbekistan, for example, in Uzbekistan, you do see people wearing glasses. And also depending on that, I don't know. Uh, anyway, let's move to the next question. Guys, there's another question. All right. Suppose that you are in Sasmo and you have 3 minutes. I just wonder, can you solve this correctly? Okay, that's very easy question. In the diagram on the right, what percentage of the grid is shaded? Okay. Sona, Maka, Musa, Daphna, I want everyone to try this. Okay. You have 3 minutes. You have enough time. Okay. And after that, we will see. If you can solve in 3 minutes, you will get a gold medal. Time starts now. Write your answer to the chat box. Makkah, are you sure?
I don't sure. I'm not sure. Is my answer.
It's not correct. Musa, did you get anything?
I got 11, but it's like first I get periodic number and then I factorize it.
So you got 11. That's also wrong answer. Miss Daphne, did you get anything? Sona, Mirza, Ivan?
No, not yet.
Not yet. Why not yet,
Teacher,
Sona? I
I
gave you
was
3 minutes.
teacher, I was thinking like a good 15 or like 17 out of 100 because I like found it out of 10, like 1.7 or something.
Hmm.
But I think it's supposed to be a little bit bigger than that because I can like imagine it in my mind, like 1.8 point like 3 or something, 185, like 18.3 percentage because like I can just put them up into shapes. But
Okay.
I also somehow think like 18 might be a little bit too much.
Okay. So here, guys, what are we going to use is maybe there are different ways using coordinate geometry. I can answer this question. Suppose that if you're given two triangles, okay, let's say their area S1 over S2, and how they are related to this their corresponding size. So that's actually its corresponding size are A1 over A2, right? That's equal to the ratio of their squares, right? If you look at this, for example, let's say this one is A and this one is B and this one is C. And let's say this one is D and this one is E. Now from here, as you see, triangle ABC is similar to triangle ADE. So that means that the area of ABC, let's say it is S1 over S2, that's equal to corresponding size. This one is corresponding size is 2 over, how about AD? AD is equal to 5. So here that's squared. That's equal to 4 over 25. And we know the area of S2, right? What is the area of S2? It is 5 times 4 over 2. So from here, we know that S2 is equal to 1 over 2 times 5 times 4. That's equal to 10. Now, if you substitute there, I will get S1. What is S1? It is 4 over 25 times 10, which is equal to, by 5, it is 8 over 5. So now what is the question? What percentage of the grid, right? So S1 over the whole grid, let's say it is S. So I need to multiply this by 100%. So what is S1 is equal to 8 over 5. And what is the area of the grid? It is 2 times 10, right? Simple is 4 times 5. That's equal to 20. Now we should multiply this by 100%. So 100 by 20, it is 5. And 5 over 5 is also 1. So that's equal to 8%. Okay, Mr. Makkah, very easy question. Also coordinate geometry, but I don't know you have studied coordinate geometry. You can just write the equation of AE, and after that this intersection point, then after that we can find this length. And after that find the area of the shaded region and divide by the area of the grid, right? That's it, multiply by 100%. Okay, guys, another question. Let's try to solve 3 more questions, okay? Find the value of the expression. 2 plus 1, 2 plus 2 over 3, 2 plus 1 over 2, 2 plus 2 over 5, 2 plus 1 over 3, and just continues until 2 plus 2 over 9. Musa, you need to write on a piece of paper. Are you just calculating mentally?
No, I'm just thinking the easy way, not like
No, I
there
don't
is
think
no.
there's any easy way here, because here we have only how many fractions? 1, 2, 3, 4, 5, 6, 7, 8. Just simplify and multiply. That's it. 2 plus 1 is 3. And here we have 3 times 2, 6. Here we have 8 over 3. And here we have 4, 5 over 3. And 7, 5 times 2, 10. Here we have 12 over 5. Right? That's it. 3 times it is 7 over 3. And 7, 14, 16 over 7. Next one is 8, 9 over 4. The last one is 18, 20 over 9. Now just cancel out the common factors, because if it goes to, a lot of terms at that time, you may think, but here we have only how many? 8, 9 fractions. So the 7, 7, they cancel each other, right? And this 9, 9, they cancel each other. And this 3, what is it? 5, 5, they cancel each other. And what else? Okay, this 3, 3, they cancel each other. And this 12 by 4, right? And also by 3. And that's it. What is left here? 8 times 16. So that's what we have here. 8 times 16 times 20 over, in the denominator, we have only 3, right? Only 3, which is equal to 8 times 6, 128. And that is 200, 2560 over 3. Do we have any other way?
Teacher, I did the same way, but just a shorter. Like, I just didn't do the certain parts the way that I should. So I got the wrong answer. And I was too greedy with myself, so I had to do it all over again. So while you were explaining the solution, I was doing it all over again.
But did we do everything correctly here? What did you get, Daphne? The same answer?
Teacher, at my second try, I got the same answer, but at
Really?
first I got like 197, 109, 100, 1973 divided by 5, which I don't know how I got. But in the second try, I did it like all over again with like longer version. I tried to do with a shorter version at first. So I did this all over again and found the same answer.
Okay, 12 over 5. Here we have 7 over 3. And 16 over 7 is 8, 9 over 4, and 20. I'm just wondering why we are having fraction number. I just wonder, did we make any mistake, or did we
Teacher, it's supposed to be a fraction.
Are you
Or
sure?
is it not?
This fraction is correct, right?
I don't know.
Until 2 over 2 over 5 and 2 plus 1 over 3. Next one will be 2 plus 2 over 7. Next one will be 2 plus 1 over 4. And next one will be 2 plus 2 over 9. I think nothing is wrong. The first one is 3. Second one is 6 plus 8 over 3. Next one is 5. Oh, it should be 5 over 2 here. Right? Because this one is 5 over 2. And 12 over 5. And 7 over 3. 16 over 7. 9 over 4. 20 over 9. Okay. So that's why we made a mistake here. Now this 3, 3. Okay, it's gone. And this 9, 9, it is gone. And what is it? This 7, 7, also it is gone. And this 2, 3, 6 with 12 is only 2 is left, right? And with this 5, 20, only 4 left. As see here, we don't have any denominator here. Now also this 4, they cancel each other. So what is left here? Here we have 8 times 5 times 2 times 16 left, which is equal to 8 times 5, 40, 40 times 2, it is 80, times 1, 6. So the last digit is 0. 8 times 6, 48. We have 4, 8 times 1, 8. With 4, it is 1, 2. Oh, the answer is 1280. Is that right, Makka?
Yes.
Do you see any mistake?
No, I can't see any mistake.
Okay.
Teacher, I do.
Where?
I don't understand, like, I understand the first two, but not the end. If you're not going to cross over the 5 at the top, we should also not at the bottom.
What do you mean?
There's a 5 there. Then it has to be 15 under.
Are you talking about this 5?
Yes.
No, this
Yes.
5 I cancel with this 5, right?
20, okay.
No, definitely. If you want, actually, this with this part we have no problem, right?
Yes, but
And
the
the second
thing
one
about
also,
this is like writing 5 or 20 shouldn't
yeah, I think
really
we have no
matter.
mistake
Because
here.
like, no, before we needed to put 4 down there, 12.
Okay.
Then it works. We get the same answer.
Now, I mean, here we are canceling this 5 with this 5, right? And here this 3 with this 3, and this 2, 4 with this 8, right? Okay. And this 7 with this 7, and 9 with this 9. And here we have 12 over 3. Here we have 4. That's it. Now 4 times 6, 64. And 2 times 64, that's equal to 1280. Now here, what we have here? We have 4 left, and 16 left, and 20 left, right? And the year product is 1280. Okay, that's it. Guys, let's solve the... Yes, Daphne, what did you say?
That was the way that I did at first, but I think I did a problem in the calculation.
Yeah, on exam day, actually, you will have different, I would say, spirit, right? And it is serious, and you have to double check and think twice. And I hope you will not make this kind of mistake, because here we are just practicing. That's why. Yeah, let's solve this question, and I will finish the class. Okay, 20. And the last 5 questions, we will do them next time. Find all possible values of x over y, where 21x squared minus 10xy plus y squared is equal to 0, where y is not equal to 0. Okay, so how can we solve this? As you see here, that is a quadratic equation in terms of x. So now if you remember, we know how to factorize this, right? This 21x, I can write it as 3x times 7x, and this y, I can write it as minus y and minus y. Because 3x times 7x, that's 21x squared, minus y times minus y, that is y squared. If you cross multiply, what do we have here? We just have here minus 7xy and minus 3xy, and the year sum is minus 10xy. Then I can factorize it as 3x minus y and 7x minus y. That's equal to 0. So since it's equal to 0, that means that each factor, right, it must be equal to 0, which means that 3x is equal to y, or 7x is equal to y. It says that x over y, right? From the first one, what is x over y? X over y is equal to 1 over 3. Or from the second one, x over y is equal to 1 over 7. What is the question? Find all possible values of x and y. So all possible values are 1 over 3 or 1 over 7. Maybe if I give you some time, we can solve this. Just a simple question, quadratic equation. But here, our constant is y. It's not some real number. Okay. All right, thank you very much. That's enough for today. Okay. We have only 3 weeks left. Try to practice this already solved questions one more time. And if you need more questions, let me know. Okay, Mr. Musa. So I will see you on Wednesday. We have only 2 days. Maybe on Wednesday, I'll give you more papers until next week. Okay. Have a good day ahead. See you on Wednesday. All right.
Okay, thank you. Bye.
Bye,
Thank
teacher.
you. Bye bye. Bye bye, Defna.